In this chapter, we're going to build a notification system for the forum application. This is a common need in SPAs and is easier than you think. The notifications in our forum application will be for notifying a user when the thread they are looking at is updated or is posted to by someone else. To prepare for this feature, let's take care of an issue that will prevent us from successfully implementing the notifications. In order to support our not found page for the thread show page, we dispatch the fetch thread action in the before enter navigation guard. Then, we also dispatch thread show again in the created hook of the thread show page. Doing this in both places sets up two snapshot events on the thread. That's going to cause issues with our notifications and really isn't necessary otherwise. So, I want to make sure that we only have a single snapshot event for the thread. To do that, let's update the fetch item action to take a once option. Using once will immediately unsubscribe from the snapshot as soon as it's created. I'll also add a console login here so that we can better visualize this working. Then, we can use the once option in the navigation guard. Lastly, we'll need to update the fetch thread action itself to take in the once option and then pass it on to the fetch item action. Now, over in the browser, when I visit a thread, I see the message logged to the console. That means we're successfully getting the thread just once in the navigation guard. Great, let's remove that console log. Now, supporting the new option like this works. However, this could get pretty tedious if we want all the specific fetch resource actions, like fetch user, fetch post, and so on, to accept the once option too, or accept any other future options for that matter. To make things easier on ourselves, let's create a helper function to generate our different fetch resource actions for us. This will be like the higher order function make append child to parent mutation. Its job will be to generate the action for us. So, the first thing we need to do for the make fetch item action function will be to take in the emoji and the resource, since this is what's different per resource. Then, we just return the function that makes up the action itself. We can just go copy and paste this from threads.js. Now, we'll make the emoji and resource reference the ones from the function argument. Then, instead of destructuring the payload, we'll just reference it directly, and then spread it into the payload of the dispatched action. This will allow us to arbitrarily add new options to the payload of the fetch item action that will automatically become supported by each of the individual fetch resource actions. While we're at it, I'll do the same thing for fetch items, plural. The only difference between the two is the action that they dispatch. Nice. And with that, we just have to use these two higher order functions. First, we'll import them, and then use them. Let's go check it out in the browser to make sure we didn't break anything. Cool. Still looks good. I'll also do the same for each of the other store modules, but I won't make you watch. The changes will be in the source code for the lesson. In Vue 3, we can write something called a composable. What is a composable? First, it's a separate file from any one component, and thus reusable between multiple components. Second, composables use the Vue 3 composition API in order to expose reactive state and or functions for use inside of other components. Thus, composables can serve similar functionality to both Mixins and Vuex. This is perfect for a notification system, as applications should be able to spin up notifications from any page or component. It's worth noting we could achieve the same thing with Vuex, but I want to show you an alternative approach, so let's do it. I'll create a composables directory, and then a file, useNotifications.js. The prefix use in the file name is a common convention used when creating composables in Vue.js. Next, we'll create and export a function called useNotifications. This is a necessary step for all composables. Then, I'll create a variable to store all the notifications in. Notice that I'm defining this variable outside of the useNotifications function. This means that no matter which component we use the composable in, they will always refer to the exact same array of notifications. This makes the composable act as a type of global store, like Vuex. We also need to make the notifications reactive. We can do that by importing the reactive function from Vue, and then calling it on the notifications. Without this, the notifications would be stuck in their initial state, and the UI wouldn't update as notifications were added or removed from the array. Calling reactive here is similar to defining reactive data in a component, except that we're not tied to any particular component. Pretty cool. Now we must expose the notifications to the components using the composable by returning it from the useNotifications function. With the notifications now exposed, I want to create a component that will be responsible for displaying them. I'll call it appNotifications.Vue. I'll just use a VS Code snippet here to quickly scaffold out the component boilerplate. The setup function you see here is a component option made for doing everything related to the composition API. So, let's import our composable and then use it inside of setup. Now, we can destructure the notifications from the object returned from the useNotifications composable. And lastly, to expose the notifications from the setup method to the rest of our component, we should return it. Inside the template now, we can print out our notifications. We haven't defined what the individual notifications look like yet, but we'll just assume each is an object with, let's say, a message property. And we'll probably also need an ID to identify each notification. I'll use that for the key attribute. Awesome! Now we can use our component in app.vue. I'm choosing to use it in app.vue because we want the notifications to be available for display on any page, much like the header. Only when the notifications array is empty, the user won't see anything different. Cool, the page looks the same, but now in the DevTools, we can see the new component. Let's hardcode a couple of notifications in there, just so we can see what they'd look like printed to the page. We said each notification would be an object with a message and an ID property. And I'll just put another one in here for good measure. Okay, let's see what that looks like. Nice, that works. We can see the notifications in the bottom left-hand corner. Let's style them a little bit so that they look more like typical notifications. I'll position them at the bottom right-hand side of the screen and give each of them their own little box to live in. Lastly, I'll make sure the div that I wrapped them in has that class of notifications. Awesome. That looks more like a notification I'm used to seeing. So, obviously, at this point, the hard coded notifications aren't what we're going for. So, let's add the ability to create new notifications. In the composable, we can create a function called add notification. It will take a notification object, like we hard coded above, and it'll push it to the notifications array. Just to make sure the function is easy to use, we can have it randomly generate its own ID for the notification. Now, with our add notification function in place, this means we can add a new notification from absolutely anywhere throughout our project. Since the goal is to notify the user when a thread's content has updated, let's use the add notification function on the thread show page. And once again, call it in the setup function. This time, getting the add notification function from the composable. Then, just to see add notification in action, let's use it to add another test notification. Now, over in the browser, everything broke. What's going on with that? Add notification is not a function. That's because we forgot to return it from our use notifications function. All right, give it a refresh now. Awesome. Our dynamically added notification has been added to the bottom of the notifications. Of course, it also makes sense that we should provide a way to remove a notification. We can do that with another function in the composable. It should take in the ID of the notification to remove, and then we can find the index of the specified notification. And use splice to remove it. Cool. Lastly, let's expose the function. With the remove function in place, we can now use it in app notifications to provide an X button on each notification in order to remove it. First, we'll deconstruct it from the composable, and then we'll return it from setup. Then we can provide the markup and use a click event listener to call it when the X is clicked. Now, when we check that out in the browser, clicking on the X removes the notification, just like we wanted. Awesome! That's super cool. We were able to add a notification in one component and then remove it in a totally different component, all without the use of UX. This nails down the basic functionality of the composable. Let's remove the hard-coded test notifications and the one added in thread show. Now, we're almost ready to start showing the appropriate notifications for an updated thread in the next lesson. Before we show the notification when the thread updates, we need a way to run a function every time the snapshot event triggers. Currently, we're resolving a promise when the snapshot fires, which is great for catching the resolved value for the first snapshot event. However, once a promise is resolved, it's resolved for good. It's never going to resolve again. Thus, we need to have the option of providing a callback function to the fetch item action. Then, if the onSnapshot function is provided and is actually a function, then we'll call it in the callback of onSnapshot. We'll also pass it the item fetched, cloning it just to be safe. It's also going to prove useful knowing what the value of the item was before it was updated. To get that, we'll find the item in the state just before its new value from the snapshot is committed. Then, we'll provide that to our callback function as well. And we'll also need to import findById from the helpers. Nice. That should do it. Finally, let's also allow fetchItems, plural, to take in an onSnapshot callback function and then pass it on to fetchItem. Now, over in the thread show page, in the created hook, we can provide the onSnapshot callback function to fetch thread. And add a notification. Also, so that the add notification function from the composable is available outside of setup, we need to return it. In the browser, if I refresh the page, we get the notification immediately. This is because onSnapshot runs the very first time, not because of an update to the data, but as part of our initial data fetching. We can handle that. Before adding the notification, we'll check async data status ready, which is only true at the end of the created hook after all the initial data is loaded. If it's false, then the initial data for the page has not all loaded yet, so the snapshot event in question is for the initial load of the data. Thus, we can return early and not add the notification. Now, in the browser, when we reload the page, we do not get the notification. However, if I open up the same page in a new tab and add a new post, you'll see I get the notification in the other tab. Very cool. However, there are two things that are still an issue. First, the tab that we make the change in shouldn't really need the notification. And secondly, the other tab doesn't have the new post shown in the thread. Let's fix these one at a time. To fix the first issue, what we really want to do is say something like, if the update was initiated locally, then don't show the notification. So, how do we know the value of is local? This is actually something we can get from the Firestore. Local rights in your application will invoke snapshot events immediately. This is because of an important feature called latency compensation. When you perform a write, your listeners will be notified with the new data before the data is sent to the backend. Retrieved documents, therefore, have a metadata has pending writes property that indicates whether the document has local changes that haven't been written to the backend yet. So, we can pass this to the onSnapshot callback and then use it in the thread show page. I'll also just clean this up a bit and check both conditions together. This time, when we create a new post, it only notifies the other browser tab. Perfect. Now, let's handle the second issue. The reason the new post doesn't show up is because while the post IDs stored in the thread are updated in the Firestore, hence the snapshot event firing, the actual post itself is never fetched. So, let's fetch the post with the ID that has been newly added to the thread. Since we're already doing this on created, along with fetching any users that might be needed for a post, let's extract that into a method that can be called in created as well as in the onSnapshot callback. I'll copy and paste it from created and change out a couple things. I'll make the function async, get the IDs from the IDs parameter, and reference the thread via the computed property. Then we'll replace what was in created before with the call to this method. We can call the method once again in onSnapshot. But how do we know which post IDs it needs? We could assume that the last ID in thread.posts is the only newly updated post. However, to be more thorough, we could instead compare the original thread.post to the updated thread.posts. This is where the item and the previous item we passed in to onSnapshot can come in handy. To get the difference between them, I'll call a Lodash function difference, which will return the items that exist in one array, but not in the other. These are the new post IDs. And of course, we'll need to import difference from Lodash. Let's see what it looks like now. Great. This time we see the notification in the other browser tab, and we get the newly added post. All right, that takes care of the notification when adding new posts. But what about when we edit the thread itself? Let's give it a try. First, I'll navigate to a thread that's mine so that I can edit it. Awesome, that works. What about editing the thread content? Hmm, that didn't work. That's because updating the thread content isn't actually updating the thread, but rather the first post of the thread. That also tells me that editing any other post in the thread is also not going to show the notification yet. We'll remedy this in the next lesson. In this lesson, we've got to listen to the on snapshot of the posts as well as the thread. That way, we can display notifications when posts are updated. We should return early for the same reasons we did before, and otherwise add the notification. Cool, let's try this out in the browser. I'll make an update to a post, and when I hit update, we do have the notification in the other browser tab. But we also got a notification in the tab that we made the edit in. Why is the isLocal variable not working as before? Let's do some console logging to find out. What? It was true, but then it fired again and was false. What in the world is going on here? We didn't have this issue with the threads. Well, it turns out the difference between the two is that when we update a post, we're providing post.edited.at with a server timestamp. This causes the flow with onSnapshot to occur just a little differently than it did before. Instead of it only firing on the local write, it fires once on the local write with a timestamp of null, and then again after the write has been completed server-side with the server timestamp. That means we need to add one more condition to our early return. So, if the previous item has an edited property, and the edited property has an at property that's falsy, in our case that's null, then we'll return early. Let's update the post again. Awesome. Now this works. There's one last issue we need to resolve. If we add a new post, you'll see that in the other browser window, we now get two notifications at a time. Now that we've got the onSnapshot callback set up for the posts as well as the thread, we don't need the thread callback to handle any notifying for adding a post. Thus, we'll check the post's length, and if it's greater than 0, then it does have new posts. In that case, we'll just fetch those new posts. Otherwise, if the thread is being updated, we'll send the notification. Perfect. Our notifications are looking great. However, different use cases for notifications require different notification behavior. For instance, sometimes it's worth showing a notification until a user closes it. This is the approach we've taken thus far. It's probably not the best for this use case, however. Instead, we probably want our notifications to close after, say, a few seconds. So, how do we extend our notification composable to be able to handle both? We could add a new property to our notification object called timeout, where we could specify a length of time to show the notification until it automatically goes away. We'll use milliseconds here, as That's what the setTimeout function uses. And we'll do the same where we call addNotification for the thread snapshot. Now, in the composable, we can check if the timeout option exists. And if it does, use it to call remove notification after the specified timeout. To access the ID to pass to remove notification, we'll need to store it in a variable first. Then we can use it in defining the notification and to use for remove notification. Lastly, I want to destructure the notification parameter just to make it a little more clear what a notification object looks like, and to clean up our code just a bit. Alright, let's see what that looks like in the browser. I'll update the thread in one tab, and in the other tab, the notification displays and then disappears after a few seconds. Perfect. We could use this same approach to add any number of useful options to our notifications, such as notification types, like success, error, warning, and so on, or adding in buttons to some notifications in order to trigger certain actions when clicked. Really, the possibilities are endless, but I'll leave all those different options up to you. Right now, our notifications are a little abrupt and kinda hard on the eyes. Let's give them some transitions to make them look nicer and more noticeable. We can do this by using the built-in Transition Group component. First, we wrap our notifications in the Transition Group component. Then, we give the transition component a name. This name will correspond to the class names that we need to target in order to animate the transition. Then, we can provide some styles based off the different states the transition group component gives to each of the notifications. This starts by giving the notification divs a transition of half a second. Then it says that right at the time the div is inserted into the DOM, give it a 0 opacity and move it over to the right 100% of its width. This class exists until one frame after the element is inserted, thus giving the element the appearance of fading in and moving to the left. The same is applied to leave, just in reverse. This style makes the notification glide smoothly to its new position once another notification is added underneath it. Alright, let's see how it looks. Oh yeah, I like that.